Good morning, students. We'll start with our today's lecture. So, in the last lecture, we had completed we had started with one small topic of the second part of this chapter, that is cloud, and we had seen the characteristics of cloud, that is on demand, self service, broad network access, resource pooling, rapid elasticity, and measured service. So this was the question being asked in 2017 paper as well as 19 paper as well. What are the characteristics of cloud? As well as now we'll start with the next topic, that is challenges in bringing virtualization to the x86 hardware. So this was cloud nowadays is or virtualization is somewhere a technique which is being used on the current hardware, that is your processors are i3 processors, i5, i7 and i10, so on. So these processors are very much compatible with the virtualization process or the cloud process. But when we talk about the old hardwares, that is the x86 architecture, how does the virtual machine work? We'll see that. Core attributes of virtual machine to x86 based target platform. So what were the core attributes? What was the actual need, or we can say what was the actual output which x86 was giving us? That was compatibility. Compatibility means it was somewhere expected that compatible platform can be given, that is consistency can be given, it could work on any of the hardware if we apply virtualization on the x86, that is on every machine. Performance is high performance. Every time when you implement something new on the technology, you expect a positive output through that, this that is through the machine or through the technique. And for that is the reason performance was the higher expectations was at higher expectations by the system management. And isolation, so isolation means virtualization actually means isolation, that is we are creating a separate set of values for an particular hardware so that we can work on it, and that is somewhere dependent on isolation. So these were the three attributes on which your virtual machine was a target to the x86 hardware. So what were the challenges? So when these things were applied, what were the challenges which were given by the x86 machine as an output? Major challenges was the x86 architecture was not virtualizable. The first and the foremost thing which was actually expected was that the new technique was not being prepared for the current technique to be applied on the older hardwares. The x86 architecture was daunting complexity. So there were many complexities as the hardware actually was complex at that time. Architecture was difficult to be manageable. That was a different at a different stage. These things were not possible. The next third one was x86 machines had diverse peripherals. They had connecting peripherals, and for that reasons it was majorly a task for people to complete. Need for simple user experience. So there was a need that simple normal user can only use it, whereas virtualization technique is n number of people can do it, that is multi user tasking it is, but that was not possible with the help of virtualization on x86, as they have told first only that x86 architecture was not properly virtualizable, that is it was not able to be accessed over n number of machines, that is multitasking and multi-user was not the criteria for x86. So this is actually your virtualizing the x86 architecture, that is your direct execution. Now your prior codes were written on binary, that is the reason binary translation was required here. That is, see, this is your x86 architecture and this is your virtual machine monitor, which is monitoring the whole machine on the dependencies of how it is working. As I have said, high level components of VMware virtual machine monitor in the absence of hardware support. So when they are replacing your virtual machine monitor with they are replacing your actual hardware with your virtual machine monitor, then this is the scenario what they have said, that is you have a virtual machine monitor in which you have the system, that is you have direct execution and you have binary translation, but your decision algorithm is working on both the things, so that you have hardware components, that is shared modules, shadow MMU, that is main memory unit, IO handling, device drivers, all those things will be there here. So for that, see here, if you can see the arrows, your decision algorithm is giving you the inputs from the user, but your direct execution is your normal machine, that is direct execution to your hardware, and binary translation also can be done, but your direct execution is also connected to your binary translation. That is, suppose I'm working on the binary machine, if I'm not available with the binary translation, my direct execution can convert the data into binary execution to replicate it to the hardware. So as per the requirement of my user, the x86 architecture was this, but there here absence of actual hardware is there. Next is virtualizing the x86 architecture. Now when they have done the virtualization, when they tried that through binary translation virtualization can be done. So binary translation must be used if any of the following is true. So when do we use binary translation? Through direct execution, when these statements which they have given are true. If they fall, that is if they are done, then we can use binary translation. First is virtual machine is currently running in kernel mode. If my virtual machine is running in kernel mode, I can use binary translation. That is the first criteria. Second criteria is virtual machine can disable interrupts and issue IO instruction. So my virtual machine, if gets disabled because of the interruptions, and that time issues occur in the IO instructions, that is input output instructions, that time we can do binary translations. And virtual machine is currently running in real mode. If my virtual machine is actually working on the actual machine for processing, that time also I can do binary translation. So what are the three criteria? Virtual machine is currently running in kernel mode. If it is in the actual mode, you can go, that is in the kernel mode. And second is virtual machine if disabled because of interrupts and is giving you issues in the IO instructions, it is not performing input and output instructions, so that time you can do binary translations. And third is if it is running in the real mode, that is your current running machine, it is there, that time also you can do the binary translation. So what is your virtual hardware platform? So why do you require, if you are preferring x86 hardware, what is the hardware platform you are using? First one is virtual x86 CPU. So x86 hardware requires, first is x86 component CPU with the same instruction set extensions as the underlying hardware CPU. That is the previous version which has all the components, the settings which will be there in the x86. Up to 512 MB of contiguous DRAM, that is dynamic RAM. See here the dynamic RAM range, that is 512. Nowadays nobody uses 512 contiguous dynamic RAM. Dynamic RAM is which keeps on changing the data. SRAM is static RAM, DRAM is dynamic RAM. So what are the backend features, or what is the somewhere what you can say, if this is my actual hardware, what are the inputs what I am getting in return because of my hardware? So this is visible to us, but in return what we are getting is this backend scheduled by the host operating system on either or either a uniprocessor or a multiprocessor host. So that totally depends on the user, that it is providing single processor or multiprocessor depending on the x86 CPU. Allocated and managed by the host OS. So page by page 512 MB will be done or will be calculated or will be managed by the host operating system page by page. So every page will be calculated, as the dynamics here are very less in storage. This is multiplexed means in connection. So next is PCI bus, fully emulated compliant PCI bus, 4 into IDE disk, 7 into bus logic SCSI disk, then 1 into CD-ROM, IDE CD-ROM, 2 into 1.4 MB floppy drives, 1 into VMware graphics card with VGA and SVGA support, 2 into serial ports COM1 and COM2. So serial porting is connections which you can give for multitasking. 1 into printer, your normal printer, 1 into keyboard, 1 into, these are the connections what your x86 hardware is giving to your system. So that is 1 ports it is giving. 3 into AMD LANs Ethernet cards. So Ethernet is also possible for networking. 1 sound blaster, that is the normal sound speaker. So these are all the connections which are there in your virtual hardware of x86. So virtual hardware configuration options on the early VMware workstation CA 2000. So it was in the year 2000. So these are the things which are there. That is this is the multiplexed one, that is the inside one, and this is the emulated one which your normal CPU system connection, your motherboard has for. Next is your role of host operating system. When they say here that your host operating system is managing your 512 MB data, that is the dynamic RAM, how is your host operating system working for your virtual machine? So role of a host operating system. So see here, this is my kernel mode and this is my user mode, and in these two modes I have two people working, that is my virtual machine context and my host operating system. So this is my actual host, means my actual system worker, and guest means which is time being come for my completion of work. So this is my particular CPU and I have a disk for storage for my CPU, that is my system. When I have an SCSI call from my virtual machine, here n number of virtual machines, I give it a write operation. Once my binary translations are done, I am connecting to the interrupt handler. My virtual machine monitor driver will make a connection with my virtual machine monitor. It will complete its task in the kernel mode, and my user mode will have only the virtual machine. But can you see these dotted lines? These dotted lines are fulfilling my work from the host side, not from the user side. So user has no connection with these things. This all here is done by my host operating system, that is looking to the virtual machine monitor, then the virtual machine monitor driver. See what driver is doing? Driver is connecting me both the sides to my virtual machine monitor as well as virtual machine extractor, that is how many virtual machines are being there in the series to get connected to the driver, which will somewhere talk to my disk, and it will have SCSI and FS and write operations as well as SCSI formattings, so that host context can be converted, and world switch is there. See your two-way switching is there, which is possible through virtual machine monitor and driver. What does a driver do? Driver takes off all the data from one place to another, which is done here both the ways, and here your virtual machine driver sends the data to the virtual machine X, that is a series of processes where there. Next is the role of host operating system, that is, see here, normal context switch is like process A and B. If two processes are there, If user A has is in the kernel space and B is also user in the kernel address space, when it is converted into a VMware, that is in the virtual machine, where what will happen is your host OS context will be both way to the VMM context. You will have one virtual machine, and you will have virtual machine monitor, and your VMX will be your user space, that is how many users have been logged in, and your kernel address space will be host OS, which will be contacting your virtual machine monitor or your virtual machine for the access of data or for virtualization. So this is the difference between your normal context switch and your VMware context. They have said world switch because n number of processes are there connected here. That is the reason this is there. So VMware hosted architecture, and it has three components: VMX, VMM driver, and the normal virtual machine monitor, which will give you this context, which is this context, and this is your normal system context, which when you are sharing the data. Next is ESX server. So priorly we were only on the host operating system. Now when we are implementing ESX server on x86 hardware, so what will be the criteria? See, there are n number of virtual machines, 1 2 3 4, and you have monitor virtual machine monitors separately for that. And for your ESX server, you have ESX hypervisor, which will run on your bare x86 hardware, so that to give the outputs here. X86 is the actual thing. On that x86 you are getting your hardware, you are getting an hypervisor, which is making an environment in such a way that it will access the hardware, but it will also access separate virtual machines with their own virtual machine monitors. They do not have a single virtual machine monitor. So this is type 1 hypervisor for ESX server, I repeat. So when ESX server virtual machine VMware's type 1 hypervisor 2, that is hypervisor, what they have said is ESX server architecture provides substantial benefits. So there are a certain benefits when you are applying ESX server methodology on your, that is on your x86 hardware. CPU scheduler ensures that each virtual machine gets a fair share of the CPU. So as there are n number of virtual machine monitors, you get a fair share, a fair timing, and an equal duration on which you can work. Next is memory manager is optimized for scalability. Scalability means high performance, which they are giving high output is possible through these ESX server. Input output subsystem is optimized for performance. So input output is also been optimized at high levels, that is it is giving you an high output performance through input and output as well. Backends also typically relied on abstractions provided by host operating system. Backend processing is also done faster because abstractions are made. Abstractions means separate modules are being made, so that work becomes faster. ESX server made it easy to introduce new capabilities. So new technologies and new capabilities were possible on x86 because of the ESX server. With this, we have completed our chapter 7. Today, probably till afternoon, I might be sending you some pending lectures of these of the chapter 6, and because we have some 2 to 3 lectures which are lacking behind. If time permits, I would be informing you and sending you those lectures as well. I'll be providing the assignment for this lecture tomorrow. Thank you.